Ionic compounds. This is another group of compounds. So we've talked about protons and neutrons and electrons inside of the atoms. And I told you that the number of protons is like the personality or the soul of the atom. In a chemical reaction, the element that the atom belongs to doesn't change. Just like if you went and got a makeover, you might look very different. You can put on different clothes, you can color your hair, do all kinds of stuff to your body, but it doesn't change who you are on the inside. In a chemical reaction, the atoms remain the same element. The number of protons doesn't change. The number of electrons, though, can change. So you can have electrons being gained or electrons being lost. And the result when that happens is that we get an ion. An ion is an atom or molecule that has a charge on it. A net positive or a net negative charge. In an ionic compound, we have ions, both positive and negative, and they're held together by electrostatic forces. Opposite charges attract, and like charges repel. Electrical forces and magnetic forces are similar in some ways, and we have more life experience with magnets. If you've ever played with Brio trains or just messed around with magnets, you know that if you put them one way, they'll stick to each other, and if you turn one of the magnets the other way, you can't get them together, or if you are able to force them together, they pop away from each other. The north pole of one magnet is attracted to the south pole of the other. Two north poles together, though, repel. Electrical charges are very much the same. Two negative charges repel each other. A positive and a negative attract each other. So I think of ionic compounds as being a lot like the magnetics building toy, or you could think of them as magnetic Lego bricks, right? And they just kind of stick together by magnetic force instead of with the little knobbies that the Legos have. So different kinds of ions. An atomic ion, we usually call it a monatomic ion. Mono is that prefix that means one, atom referring to an atom. A monatomic ion is just one atom with a positive or negative charge. So if we have a positive charge, we call it a cation. Let's look at sodium. How many protons does sodium have? It's on the periodic table. Sodium has 11, right? So sodium is element number 11. It has 11 protons. How many electrons does it have? 11. So it has 11 electrons and 11 protons. The protons have a positive charge. If it loses one electron, so now we've got 11 protons still, but only 10 electrons. What's the overall charge? Positive 1. And so we write that like this, Na with a positive sign. It's not one positive, it's just positive because we don't like to write the number 1. That's a cation. Cations are positive. Anions are negative, and you have to figure out some way to remember these. I like cats. I have positive feelings towards cats, even though I did step in cat vomit barefoot yesterday morning. But I still like the cat. Positive feelings for cats, cations are positives. If you hate cats, you're going to have to find something else. Sorry. Anions are negative. Negative ions, anions come about because an atom gains an electron. So how many protons does chlorine have? 17. And how many electrons? 17. Because in a neutral atom, the number of protons equals the number of electrons. Well, an atom that gains an electron, it still has 17 protons. Now it has 18 electrons. Now overall, it has a negative 1 charge, and that is this ion, Cl-. So we indicate the charges with a superscript. Atoms can also gain or lose more than 1 electron. So gaining 1 electron gets you a -1 charge, losing 1 electron gives you a +1 charge. What if you gain 3 electrons? Well, phosphorus does that. When phosphorus gains 3 electrons, it becomes P3-. Oxygen gains 2 electrons. Calcium loses 2 electrons. So we write the number of the charge first and the sign after it. So if you have a multiple charge, the number goes first and then the sign. This is different from how we write exponents in math. I like to make up reasons for things. I don't know, maybe sometimes my reasons are correct. I really don't care. It just helps me remember something. If I had the variable p raised to the -3rd power, it would be p -3, right? This would be math. This would be a variable raised to a power. This is a chemical formula. We put the number first and then the sign. If I had c², I wouldn't write the sign because mathematicians don't write the positive sign. They leave that off. They write a negative if they need it. But in chemistry, we always write the sign, and then we put the number in if we need it. So if this was an ion, it would be C2+. So they're different. Just pointing that out. This is important. Oops, I thought I was drawing a box. Metals tend to form cations, nonmetals tend to form anions. Non-metal, negative. So nonmetals form negative ions. So let's look at monatomic anions. These are the nonmetals. Nonmetals form anions, and their charges are predictable. Their charges are equal to their group number -8. So let's look at nitrogen. So nitrogen is a nonmetal. We know that because it's on the right side of the stair-step line. What group number is nitrogen in? It's up there on the wall.
7.
It's element number 7, but I want the group number, the number at the top of the column. It's in group 5, 5A. It's also numbered 15. I don't like that number. 5A, there's a relationship, though, between the 5A and the 15, isn't there? Just get rid of the 1 in front of the 5, and then they're the same. What's 5 minus 8? -3. So this is N3 minus. How about bromine? What group is bromine in?
7.
Group 7. 7 minus 8 is -1. Bromine has a -1 charge. We just write the negative sign. How about sulfur? What group is sulfur in? 6. 6 minus 8 is -2. So sulfur, 2 minus. The nonmetals all do that. They're very nice that way. When we name these anions, we change the ending of the name, a lot like we did with the molecular compounds. We just change the ending to "ide," and then it's nice to put the word ion in there. So let's name these 3 that we just came up with. N is nitrogen, and so that would be nitride ion. And Br minus would be what? Br is bromine, bromide. And how about S2 minus? Sulfide ion.
Does it always end with the ID?
Yes. So these nonmetal anions You always change the ending of the name to "ide." I think of the nonmetals as being feminine and the metals as being masculine. And so I think of, traditionally, who changes their last name? Who changes the ending of their name when they get married? The man or the woman? The woman, traditionally. Okay, I'm not commenting on current practice or anything like that, just tradition, okay? So the nonmetals change the end of their name when they become part of a compound. A compound is a little bit like, two people coming together and getting married, starting a family. I have lots of strange analogies for this. Okay, so let's write formulas for these ions. The fluoride ion is from which element? Fluorine. What's the symbol for fluorine? F. How do you know what the charge on the ion is? Group number -8. It's in group 7, right? So what's the charge? The charge is -1, and so it's F-. That's the fluoride ion. Group number -8. 7 minus 8 is -1. Magic. The 8 comes from magic. Because that's how it works out for the group number -8 to equal the charge. That's the simplest explanation. Yes?
Because of the valence electron?
It has to do with valence electrons, yeah. I'll show you another way to predict the charges in a minute. So nitride ion. Did this by accident on the previous page. N3-. It's in group number 5. 5 minus 8, -3. How about phosphide ion? What would the formula be? P3-. This is a little bit like the games that my middle school and high school boy like to pull on us, roll the dice and how many polar bears are sitting around the holes in the ice. And, these little tricks, right? And you have to figure out, is it something in how they're holding their hands? Is it a certain word they said? Or what's the clue to these things that they just magically come up with? Once you get the trick, then you can play along and puzzle other people, right? So this is like one of those games, except most students don't think it's all that fun, but whatever. Let me jump ahead just here real quick. So ignore these guys for right now. This is what we're looking at. So these are the nonmetals and the ions that they form. We're not going to see this carbon ion very often. We're not going to see this tellurium one very often either. But the rest of these are very common. So you can take the group number 7 minus 8 and you get -1 for all of these. Group number 6 minus 8 and you get -2. So that works. The other way that works is less mathematical. Let's pretend we're playing a board game. And over here, this is the starting position. And how many spaces backwards to get to nitrogen? -1, -2, -3. Nitrogen has a 3- charge. How about selenium? Well, we're going to start on this far right and move backwards. -1, -2. How about chlorine? We'll start here, we go back -1. So if that works for you, do it that way. You're just counting backwards. -1, -2, -3. Any questions about the anions? Let's talk about the cations. So metals form cations. They do so by losing electrons. Metals in groups 1A, 2A, and 3A form cations where the charge is equal to the group number. And to name these ions, the ion name is the same as the element name. You just toss the word ion on the end. So the metals are like men, they don't change their names when they get married, right? Except maybe, no, they don't change anything. So what are some examples? Let's see. How about potassium? K. What kind of an ion? What's the charge on an ion for potassium? What group is it in?
What's the charge?
+1 charge. It's in group 1, so it's a +1 charge, so it would be K+. The name of that ion is just potassium ion. Just the element name and just say it's an ion. How about magnesium? Magnesium ion well, what's the symbol for magnesium? Mg. What group is it in? 2. So the charge is close. It's +2. So the non-metals are negative. They both start with N. The metals are positive. So magnesium ion would be Mg2+. How about aluminum ion? What's the symbol for aluminum? Al. We call him Al. What group is aluminum in? It's in group 3A. So the charge is 3+.